Okay, let's take a look at example 2 here. So again, we're trying to prove that there's a scale factor and see what that is. So what you're going to notice on this first, or this pretty quickly, is this is a weird sort of looking shape. So let's first draw it out and see what we have here. We have the center. We have 0, 5, which is where T is. We have 9, 5, so 9, 5, which is where U is. And then we have 9, 0, which is where V is. So what we have here is a rectangle. Okay? And they don't really show it very well in this picture, but we want to look at is where the prime image is, right? Where the image is, not the pre-image. So the red is your pre-image. And then we have 6, 5 is U prime. And we have 6, 0 is V prime. What they don't really show very well is that C prime is at 0, 0, and T prime is here. So what we want to do is we want to decide, is this a dilation? So let's go through our steps here again. The first thing we want to do is verify that all the angles are preserved and we have the same basic orientation. So we do notice that in both the red and the green, both of them, all the angles are 90 degrees. It is still a rectangle. Okay, that's the first thing. The next thing we want to do is look at the parallel sides, right? We want to look for the opposite sides of parallel, or the corresponding sides of parallel. So TU and T prime, U prime are indeed parallel. They're actually on the same line. U prime, V prime, and UV are parallel. They're both vertical. And then you want to do the same thing for the bottom too. So all the corresponding sides are indeed parallel. Okay. So the next thing is to verify the distance of the corresponding sides have changed by a common scale factor. So this is where we want to look at what happens. So I can use my points to kind of map this, or you can just kind of look at the lengths of the sides and see what happens. So TU, let's use red since we're talking about the original TU. TU had a length of 9, right? T prime, U prime has a length of 6. Now, how do you get from 9 to 6? You would multiply by 2/3. Okay? So, how do you get that? You take 6 divided by 9, which reduces to 2/3. Okay, you take the length, right, of the image, and you divide it by the length of the pre-image. Okay, so obviously that's if this is going to indeed be a scale factor, we're indeed talking about a reduction, right? Because it got smaller. The green rectangle is smaller than the red rectangle. All right, so we want to check the bottom, see if that happened for the bottom too. So C to V is 9, and C prime to V prime is 6. So it's going to be the exact same thing. Okay, so we're looking good so far. It looks like scale factor 2/3. Here's where we're going to run into our problem, and I'm kind of giving you a hint here. Again, this is our center, right? So we need to count vertically, because that scale factor has to work horizontally and vertically. So we have a vertical change of 5, right? So C to T is 5, and C prime to T prime is also 5, which means we have a scale factor of 1. We have 2 different scale factors. And that's enough right there to let us know that this is indeed not a scale factor dilation. It's not a dilation, right? Because the dilation has to work horizontally and vertically. It can't just be one or the other. You can't just smush in one side. It's the whole shape compressed down. For this to be correct, you would have to do 2/3 of 5. Which is not a nice number, but it would be somewhere in this area. And so your rectangle would be more like that. Okay, it would compress in horizontally and vertically. All right. So this one does not work. Okay, not. All right, and then we've got one more example, example 3. This one's a short one. The next one hopefully will be pretty short as well.